Australian Information Security Manual. In audiobook format. Please subscribe and like for more content. Part 9. This part of the audiobook will cover the following sections. Guidelines for ICT equipment. ICT equipment usage. ICT equipment maintenance and repairs. ICT equipment sanitization and destruction. ICT equipment disposal. Guidelines for media. Media usage. Media sanitization, media destruction. Media disposal. Let's begin. Guidelines for evaluated products. Evaluated product acquisition. Evaluated products. An evaluated product provides a level of assurance in its security functionality that an unevaluated product does not. To assist in providing this assurance, the Australian Cyber Security Centre, ACSC, performs product evaluations through the following programs. Enterprise Mobility Evaluation Program, for enterprise mobility products used to protect sensitive or classified data. High Assurance Evaluation Program, for products used to protect secret and top secret data. The Australian Certification Authority within the ACSC also certifies product evaluations conducted by licensed commercial facilities, in accordance with the common criteria, as part of the Australian Information Security Evaluation Program, AISP. For an organization seeking to procure evaluated products, the Common Criteria Certified Products List contains a list of products that have been evaluated and certified in accordance with the common criteria. Alternatively, the ACSC can be contacted for information on both products that are in evaluation as well as those that have completed evaluation via the Enterprise Mobility Evaluation Program or the High Assurance Evaluation Program. Cryptographic Evaluations. The common criteria leverages the Cryptographic Algorithm Validation Program for the evaluation of cryptographic algorithms used by cryptographic modules within evaluated products. All cryptographic evaluations are performed by cryptographic and security testing laboratories that are accredited by the United States National Voluntary Laboratory Accreditation Program to International Organization for Standardization/International Electrotechnical Commission 17025-2017, General Requirements for the Competence of Testing and Calibration Laboratories. Protection Profiles. A protection profile, PP, is a technology-specific document that defines the security functionality that must be included in a common criteria evaluated product to mitigate specific cyber threats. PPs can be published by a recognized Common Criteria Recognition Arrangement, CCRA, scheme or by the CCRA body itself. PPs published by the CCRA body are referred to as collaborative PPs. The ACSC recognizes all PPs listed on the Common Criteria website in addition to those listed on the ACSC's website. Where a PP does not exist, an evaluation based on an Evaluation Assurance Level, EAL, may be accepted. Such evaluations are capped at EAL2+, as this represents the best balance between completion time and meaningful security assurance gains. Evaluation documentation. An organization choosing to use common criteria evaluated products can determine their suitability by reviewing their evaluation documentation. This includes the Security Target and Certification Report. Products that are undergoing a common criteria evaluation will not have published evaluation documentation. However, documentation can be obtained from the ACSC if a product is being evaluated through the AISP. For a product that is in evaluation through a foreign scheme, the product's vendor can be contacted directly for further information. Evaluated product selection. A common criteria evaluation is traditionally conducted at a specified EAL. However, evaluations against a PP exist outside of this scale. Notably, while products evaluated against a PP will fulfill the common criteria EAL requirements, the EAL number will not be published. Security control. If procuring an evaluated product, a product that has completed a PP-based evaluation is selected in preference to one that has completed an EAL-based evaluation. Delivery of evaluated products. It is important that an organization ensures that products they purchase are the actual products that are delivered. In the case of evaluated products, if the product delivered differs from an evaluated version, then the assurance gained from the evaluation may not necessarily apply. Packaging and delivery practices can vary greatly from product to product. For most evaluated products, standard commercial packaging and delivery practices are likely to be sufficient. However, in some cases more secure packaging and delivery practices, including tamper-evident seals and secure transportation, may be required. In the case of the digital delivery of evaluated products, vendor-supplied checksums can often be used to ensure the integrity of software that was delivered. Security control. Evaluated products are delivered in a manner consistent with any delivery procedures defined in associated evaluation documentation. Security control. When procuring high-assurance ICT equipment, the ACSC is contacted for any equipment-specific delivery procedures. Evaluated product usage. Evaluated configuration. An evaluated product is considered to be operating in an evaluated configuration if functionality that it uses was in the scope of the evaluation and it is implemented in the specified manner. Only product updates that have been assessed through maintenance and re-evaluation activities, known as assurance continuity, have been applied. The environment complies with assumptions or organizational security policies stated in the evaluation documentation. Unevaluated configuration. An evaluated product is considered to be operating in an unevaluated configuration when it does not meet the requirements of the evaluated configuration and guidance provided in its certification report. Patching evaluated products. In the majority of cases, the latest patched version of an evaluated product will be more secure than an older unpatched version. While the application of patches will not normally place an evaluated product into an unevaluated configuration, some vendors may include new functionality which has not been evaluated with their patches. In such cases, an organization should use their judgment to determine whether this deviation from the evaluated configuration constitutes additional security risk or not. Installation and configuration of evaluated products. Product evaluation provides assurance that a product's security functionality will work as expected when operating in a clearly defined configuration. The scope of the evaluation specifies the security functionality that can be used and how a product is to be configured and operated. Using an evaluated product in an unevaluated configuration could result in the introduction of security risks that were not considered as part of the product's evaluation. Security control. Evaluated products are installed, configured, administered and operated in accordance with vendor guidance and evaluation documentation. Security control. High assurance ICT equipment is installed, configured, administered and operated in accordance with guidance produced by the ACSC. Use of high-assurance ICT equipment in unevaluated configurations. Given the value of data being protected by high-assurance ICT equipment, it should always be operated in an evaluated configuration. Security control. High-assurance ICT equipment is always operated in an evaluated configuration. Guidelines for ICT equipment. ICT equipment usage. ICT equipment management policy. Since ICT equipment is capable of processing, storing or communicating sensitive or classified data, it is important that an ICT equipment management policy is developed and implemented to ensure that ICT equipment, and the data it processes, stores or communicates, is protected in an appropriate manner. Security control. An ICT equipment management policy is developed and implemented. ICT equipment register. Maintaining and regularly verifying a register of authorized ICT equipment can assist an organization in tracking legitimate ICT equipment as well as determining whether unauthorized ICT equipment, such as workstations, servers and network devices, have been introduced into their organization. Security control. An ICT equipment register is maintained and verified on a regular basis. Labeling ICT equipment. Applying protective markings to ICT equipment assists to reduce the likelihood that a user will accidentally input data into it that it is not approved for processing, storing or communicating. While text-based protective markings are typically used for labeling ICT equipment, there may be circumstances where color-based protective markings or other marking schemes need to be used instead. In such cases, the marking scheme will need to be documented and personnel will need to be trained in its use. Security control. ICT equipment, with the exception of high-assurance ICT equipment, is labeled with protective markings reflecting its sensitivity or classification. Labeling high-assurance ICT equipment. High-assurance ICT equipment often has tamper-evident seals placed on its external surfaces. To assist users in noticing changes to these seals, and to prevent functionality being degraded, an organization should limit the use of labels on high-assurance ICT equipment. Security control. The Australian Cyber Security Centre, ACSC's approval is sought before applying labels to external surfaces of high-assurance ICT equipment. Classifying ICT equipment. The purpose of classifying ICT equipment is to acknowledge the sensitivity or classification of data that it is approved for processing, storing or communicating. Classifying ICT equipment also assists in ensuring that the appropriate sanitization, destruction and disposal processes are followed at the end of its life. Security control. ICT equipment is classified based on the highest sensitivity or classification of data that it is approved for processing, storing or communicating. Handling ICT equipment. When ICT equipment displays, processes, stores or communicates sensitive or classified data, it will need to be handled as per the sensitivity or classification of that data. However, applying encryption to media within the ICT equipment may change the manner in which it needs to be handled. Any change in handling needs to be based on the original sensitivity or classification of data residing on media within the ICT equipment and the level of assurance in the cryptographic equipment or software being used to encrypt it. Security control. ICT equipment is handled in a manner suitable for its sensitivity or classification. ICT equipment maintenance and repairs. Maintenance and repairs of high-assurance ICT equipment. Due to the nature of high-assurance ICT equipment, it is important that ACSC's approval is sought before any maintenance or repairs are undertaken. Security control. The ACSC's approval is sought before undertaking any maintenance or repairs to high-assurance ICT equipment. On-site maintenance and repairs. Undertaking unauthorized maintenance or repairs to ICT equipment could impact its integrity. As such, using appropriately cleared technicians to maintain and repair ICT equipment on site is considered the most secure approach. This ensures that if data is disclosed during the course of maintenance or repairs, the technicians are aware of the requirements to protect such data. An organization choosing to use uncleared technicians to maintain or repair ICT equipment should be aware of the requirement for cleared personnel to escort uncleared technicians during maintenance or repair activities. Security control. Maintenance and repairs of ICT equipment is carried out on site by an appropriately cleared technician. Security control. If an uncleared technician is used to undertake maintenance or repairs of ICT equipment, the ICT equipment and associated media is sanitized before maintenance or repair work is undertaken. Security control. If an uncleared technician is used to undertake maintenance or repairs of ICT equipment, the technician is escorted by someone who is appropriately cleared and briefed. Takes due care to ensure that data is not disclosed. Takes all responsible measures to ensure the integrity of the ICT equipment. Has the authority to direct the technician. Is sufficiently familiar with the ICT equipment to understand the work being performed. Off-site maintenance and repairs. An organization choosing to have ICT equipment maintained or repaired off-site should do so at facilities approved for handling the sensitivity or classification of the ICT equipment. However, an organization may be able to sanitize the ICT equipment prior to transport and subsequent maintenance or repair activities to change how it needs to be handled. Security control. ICT equipment maintained or repaired off-site is done so at facilities approved for handling the sensitivity or classification of the ICT equipment. Inspection of ICT equipment following maintenance and repairs. Following the maintenance or repair of ICT equipment, it is important that the ICT equipment is inspected to ensure that it retains its approved software configuration and that no unauthorized modifications have been made by technicians. Security control. Following maintenance or repair activities for ICT equipment, the ICT equipment is inspected to confirm it retains its approved software configuration and that no unauthorized modifications have taken place. ICT equipment sanitization and destruction. ICT equipment sanitization processes and procedures. Documenting processes and procedures for ICT equipment sanitization will ensure that an organization carries out ICT equipment sanitization in an appropriate and consistent manner. Security control. ICT equipment sanitization processes, and supporting ICT equipment sanitization procedures, are developed and implemented. ICT equipment destruction processes and procedures. Documenting processes and procedures for ICT equipment destruction will ensure that an organization carries out ICT equipment destruction in an appropriate and consistent manner. Security control. ICT equipment destruction processes, and supporting ICT equipment destruction procedures, are developed and implemented. Sanitizing ICT equipment. When sanitizing ICT equipment, any media within the ICT equipment should be removed or sanitized. Once any media has been removed or sanitized, ICT equipment can be considered sanitized. However, if media cannot be removed or sanitized, the ICT equipment should be destroyed as per media destruction requirements. Media typically found in ICT equipment includes electrostatic memory devices, such as laser printer cartridges used in multifunction devices, MFDs, non-volatile magnetic memory, such as hard disks, non-volatile semiconductor memory, such as flash cards and solid-state drives, volatile memory, such as random access memory sticks. Security control. ICT equipment containing media is sanitized by removing the media from the ICT equipment or by sanitizing the media in situ. Security control. ICT equipment that cannot be sanitized is destroyed. Sanitizing highly sensitive ICT equipment. ICT equipment located overseas that has processed, stored or communicated Australian eyes only, osteo, or Australian Government Access Only, AGAO, data can have more severe consequences for Australian interests if not sanitized appropriately. Security control. ICT equipment, including associated media, that is located overseas and has processed, stored or communicated osteo or AGAO data, is sanitized in situ. Security control. ICT equipment, including associated media, that is located overseas and has processed, stored or communicated osteo or AGAO data that cannot be sanitized in situ, is returned to Australia for destruction. Destroying high-assurance ICT equipment. Due to the nature of high-assurance ICT equipment, and many of the protective mechanisms it employs, sanitization alone is not sufficient prior to its disposal. As such, all high-assurance ICT equipment should be destroyed prior to its disposal. Security control. High-assurance ICT equipment is destroyed prior to its disposal. Sanitizing printers and multifunction devices. When sanitizing printers and MFDs, the printer cartridge or MFD print drum should be sanitized in addition to the removal or sanitization of any media. This can be achieved by printing random text with no blank areas on each color printer cartridge or MFD print drum. In addition, image transfer rollers and platens can become imprinted with text and images over time and should be destroyed if any text or images have been retained. Finally, any paper jammed in the paper path should be removed. When printer cartridges and MFD print drums cannot be sanitized due to a hardware failure, or when they are empty, there is no other option available but to destroy them. Printer ribbons cannot be sanitized and should be destroyed. Security control. At least 3 pages of random text with no blank areas are printed on each color printer cartridge or MFD print drum. Security control. MFD print drums and image transfer rollers are inspected and destroyed if there is remnant toner which cannot be removed or a print is visible on the image transfer roller. Security control. Printer and MFD platens are inspected and destroyed if any text or images are retained on the platen. Security control. Printers and MFDs are checked to ensure no pages are trapped in the paper path due to a paper jam. Security control. When unable to sanitize printer cartridges or MFD print drums, they are destroyed as per electrostatic memory devices. Security control. Printer ribbons in printers and MFDs are removed and destroyed. Sanitizing televisions and computer monitors. All types of televisions and computer monitors are capable of retaining data if mitigating measures are not taken during their lifetime. Cathode ray tube monitors and plasma screens can be affected by burn-in, while liquid crystal display and organic light-emitting diode screens can be affected by image persistence. Televisions and computer monitors can be visually inspected by turning up the brightness and contrast to their maximum level to determine if any data has been burned into or persists on the screen. If burn-in or image persistence is removed by this activity, televisions and computer monitors can be considered sanitized. However, if burn-in or persistence is not removed through these measures, televisions and computer monitors cannot be sanitized and should be destroyed. If televisions or computer monitors cannot be powered on, such as due to a faulty power supply, they cannot be sanitized and should be destroyed. Security control. Televisions and computer monitors with minor burn-in or image persistence are sanitized by displaying a solid white image on the screen for an extended period of time. Security control. Televisions and computer monitors that cannot be sanitized are destroyed. Sanitizing network devices. As network devices can store network configuration data or credentials in their memory, the memory should be sanitized prior to the disposal of the network devices. The correct method to sanitize network devices will depend on their configuration and the type of memory they use. As such, device-specific guidance provided in evaluation documentation, or vendor sanitization guidance, should be consulted to determine the most appropriate method to sanitize memory and network devices. Security control. Memory and network devices is sanitized using the following processes, in order of preference. Following device-specific guidance provided in evaluation documentation. Following vendor sanitization guidance. Loading a dummy configuration file, performing a factory reset and then reinstalling firmware. Sanitizing fax machines. As fax machines can store pages that are ready for transmission in their memory, the memory should be sanitized prior to the disposal of the fax machines. This can be achieved by removing the paper tray, transmitting a fax message with a minimum length of 4 pages, then reinstalling the paper tray and allowing a fax summary page to be printed. In addition, any paper that becomes trapped in the paper path should be removed prior to disposal. Security control. The paper tray of the fax machine is removed, and a fax message with a minimum length of 4 pages is transmitted, before the paper tray is reinstalled to allow a fax summary page to be printed. Security control. Fax machines are checked to ensure no pages are trapped in the paper path due to a paper jam. ICT equipment disposal. ICT equipment disposal processes and procedures. Documenting processes and procedures for ICT equipment disposal will ensure that an organization carries out ICT equipment disposal in an appropriate and consistent manner. Security control. ICT equipment disposal processes, and supporting ICT equipment disposal procedures, are developed and implemented. Disposal of ICT equipment. Before ICT equipment can be released into the public domain, it needs to be sanitized, destroyed or declassified. As sanitized, destroyed or declassified ICT equipment still presents a security risk, albeit very minor. An appropriate authority needs to formally authorize its release into the public domain. Furthermore, as part of disposal processes, removing labels and markings indicating the owner, sensitivity, classification or any other marking that can associate ICT equipment with its prior use will ensure it does not draw undue attention following its disposal. Security control. Labels and markings indicating the owner, sensitivity, classification or any other marking that can associate ICT equipment with its prior use are removed prior to its disposal. Security control. When disposing of ICT equipment that has been designed or modified to meet emanation security standards, the ACSC is contacted for requirements relating to its disposal. Security control. Following sanitization, destruction or declassification, a formal administrative decision is made to release ICT equipment, or its waste, into the public domain. Guidelines for media. Media usage. Media management policy. Since media is capable of storing sensitive or classified data, it is important that a media management policy is developed and implemented to ensure that all types of media, and the data it stores, is protected in an appropriate manner. In many cases, an organization's media management policy will be closely tied to their removable media usage policy. Security control. A media management policy is developed and implemented. Removable media usage policy. Establishing a removable media usage policy can decrease the likelihood and consequence of data spills, data loss and data theft. In doing so, a removable media usage policy will likely cover the following. Permitted types and uses of removable media. Registration and labeling of removable media. Handling and protection of removable media. Reporting of lost or stolen removable media. Sanitization or destruction of removable media at the end of its life. Security control. A removable media usage policy is developed and implemented. Removable media register. Maintaining and regularly verifying a register of removable media can assist an organization in tracking and accounting for authorized removable media as well as identifying any non-authorized removable media in use within their organization. Security control. A removable media register is maintained and verified on a regular basis. Labeling media. Labeling media helps personnel to identify its sensitivity or classification and ensure that appropriate measures are applied to its storage, handling and use. While text-based protective markings are typically used for labeling media, there may be circumstances where color-based protective markings or other marking schemes need to be used instead. In such cases, the marking scheme will need to be documented and personnel will need to be trained in its use. Security control. Media, with the exception of internally mounted fixed media within ICT equipment, is labeled with protective markings reflecting its sensitivity or classification. Classifying media. Media that is not correctly classified could be stored and handled inappropriately, accessed by personnel who do not have an appropriate security clearance or used with systems it is not authorized to be used with. Security control. Media is classified to the highest sensitivity or classification of data it stores, unless the media has been classified to a higher sensitivity or classification. Security control. Media is only used with systems that are authorized to process, store or communicate its sensitivity or classification. Reclassifying media. Some activities may necessitate or allow for a change to the sensitivity or classification of media. For example, when media is connected to a system that lacks a mechanism through which read-only access can be ensured, when media is sanitized or destroyed, or when data stored on media is subject to a sensitivity or classification change. Security control. Any media connected to a system with a higher sensitivity or classification than the media is reclassified to the higher sensitivity or classification, unless the media is read-only or the system has a mechanism through which read-only access can be ensured. Security control. Before reclassifying media to a lower sensitivity or classification, the media is sanitized or destroyed, and a formal administrative decision is made to reclassify it. Handling media. As media can be easily misplaced or stolen, measures should be put in place to protect data stored on it. In some cases, applying encryption to media may change the manner in which it needs to be handled. Any change in handling needs to be based on the original sensitivity or classification of the media and the level of assurance in the cryptographic equipment or software being used to encrypt it. Security control. Media is handled in a manner suitable for its sensitivity or classification. Security control. All data stored on media is encrypted. Sanitizing media before first use. Sanitizing media before first use can assist in reducing cyber supply chain risks, such as new media containing malicious code. In addition, sanitizing media before first use in a different security domain can prevent potential data spills from occurring. Security control. Media is sanitized before it is used for the first time. Security control. Media is sanitized before it is reused in a different security domain. Using media for data transfers. An organization transferring data between systems belonging to different security domains is strongly encouraged to use write-once media. When done properly, such as using non-rewritable compact disks that have been finalized, this will ensure that data from the destination system cannot be accidentally transferred, or maliciously exfiltrated, onto the media used for the data transfer and then onto another system, such as the original source system. Alternatively, if suitable write-once media is not used, the destination system should have a mechanism through which read-only access can be ensured, such as via a read-only device or hardware write blocker. However, the use of read-only mechanisms is not immune to failure or compromise, therefore, rewritable media should still be sanitized following each data transfer. It is important to note that for most non-volatile flash memory media, it will be possible to sanitize and reclassify it following a data transfer in order to allow it to be connected to other systems again. This is not possible for secret and top-secret non-volatile flash memory media as it cannot be reclassified following sanitization. Security control. When transferring data manually between two systems belonging to different security domains, write-once media is used unless the destination system has a mechanism through which read-only access can be ensured. Security control. When transferring data manually between two systems belonging to different security domains, rewritable media is sanitized after each data transfer. Media sanitization. Hybrid hard drives. When sanitizing hybrid hard drives, separate the non-volatile magnetic media from the circuit board containing non-volatile flash memory media and sanitize each separately. Solid-state drives. When sanitizing solid-state drives, the method for sanitizing non-volatile flash memory media applies. Media sanitization processes and procedures. Using approved methods to sanitize media provides a level of assurance that, to the extent possible, no data will be left following sanitization. The methods described in these guidelines are designed not only to prevent common data recovery practices but also to protect from those that could emerge in the future. Security control. Media sanitization processes, and supporting media sanitization procedures, are developed and implemented. Volatile media sanitization. When sanitizing volatile media, the specified time to wait following the removal of power is based on applying a safety factor to the time recommended by research into preventing the recovery of data. If readback cannot be achieved following the overwriting of volatile media, or data persists, it will need to be destroyed. Security control. Volatile media is sanitized by removing its power for at least 10 minutes. Security control. Secret and top-secret volatile media is sanitized by overwriting it at least once in its entirety with a random pattern followed by a readback for verification. Treatment of volatile media following sanitization. Research suggests that short-term remnants effects are likely in volatile media. For example, up to minutes at normal room temperatures and up to hours in extremely cold temperatures. Furthermore, some volatile media can suffer from long-term remnants effects resulting from physical changes due to the continuous storage of static data for extended periods of time. It is for these reasons that under certain circumstances top-secret volatile media retains its classification following sanitization. Typical circumstances preventing the reclassification of top-secret volatile media include a static cryptographic key being stored in the same memory location during every boot of a device, or a static image being displayed on a device and stored in volatile media for a period of months. Security control. Following sanitization, top-secret volatile media retains its classification if it stored static data for an extended period of time, or had data repeatedly stored on or written to the same memory location for an extended period of time. Non-volatile magnetic media sanitization. Non-volatile magnetic media encompasses non-volatile magnetic hard drives, tape drives and floppy disks. While non-volatile magnetic tape drives and floppy disks can be sanitized by overwriting them at least once, or 3 times if pre-2001 or under 15 GB, in their entirety with a random pattern followed by a readback for verification, additional considerations apply to non-volatile magnetic hard drives due to their use of a host-protected area, device configuration overlay table and growth defects table. Both the host-protected area and device configuration overlay table of non-volatile magnetic hard drives are normally not visible to a computer's unified extensible firmware interface or operating system. Therefore, any sanitization of the readable sectors of non-volatile magnetic hard drives will leave any data contained in sectors listed in the host-protected area and device configuration overlay table untouched. Some sanitization programs include the ability to reset non-volatile magnetic hard drives to their default state, thereby removing any host-protected areas or device configuration overlays. This allows the sanitization program to see the entire contents of non-volatile magnetic hard drives during subsequent sanitization processes. Modern non-volatile magnetic hard drives automatically reallocate space for bad sectors at a hardware level. These bad sectors are maintained in what is known as the growth defects table or G-list. If data was stored in a sector that was subsequently added to the growth defects table, sanitizing the non-volatile magnetic hard drive will not overwrite such data. While these sectors may be considered bad by non-volatile magnetic hard drives, quite often this is due to the sectors no longer meeting expected performance norms and not due to an inability to read or write to them. The Advanced Technology Attachment, ATA, Secure Erase command was built into the firmware of post-2001 non-volatile magnetic hard drives and is able to access sectors that have been added to the growth defects table. Modern non-volatile magnetic hard drives also contain a primary defects table or P-list. The primary defects table contains a list of bad sectors found during post-production processes. No data is ever stored in sectors listed in the primary defects table as they are marked as inaccessible before non-volatile magnetic hard drives are used for the first time. Security control. Non-volatile magnetic media is sanitized by overwriting it at least once, or 3 times if pre-2001 or under 15 GB, in its entirety with a random pattern followed by a readback for verification. Security control. The host-protected area and device configuration overlay table are reset prior to the sanitization of non-volatile magnetic hard drives. Security control. The add a secure erase command is used, in addition to block overwriting software, to ensure the growth defects table of non-volatile magnetic hard drives is overwritten. Treatment of non-volatile magnetic media following sanitization. Due to concerns with the sanitization processes for non-volatile magnetic media, secret and top-secret non-volatile magnetic media retains its classification following sanitization. Security control. Following sanitization, secret and top-secret non-volatile magnetic media retains its classification. Non-volatile erasable programmable read-only memory media sanitization. When sanitizing non-volatile erasable programmable read-only memory, EPROM, 3 times the manufacturer's specification for ultraviolet erasure time should be applied to provide additional certainty in sanitization processes. Security control. Non-volatile EPROM media is sanitized by applying 3 times the manufacturer's specified ultraviolet erasure time and then overwriting it at least once in its entirety with a random pattern followed by a readback for verification. Non-volatile electrically erasable programmable read-only memory media sanitization. A single overwrite with a random pattern is considered suitable for sanitizing non-volatile electrically erasable programmable read-only memory, EEPROM, media. Security control. Non-volatile EEPROM media is sanitized by overwriting it at least once in its entirety with a random pattern followed by a readback for verification. Treatment of non-volatile erasable and electrically erasable programmable read-only memory media following sanitization. As little research has been conducted into the recovery of data from non-volatile EPROM and EEPROM media, secret and top-secret EPROM and EEPROM media retains its classification following sanitization. Security control. Following sanitization, secret and top-secret non-volatile EPROM and EEPROM media retains its classification. Non-volatile flash memory media sanitization. For non-volatile flash memory media, a technique known as where leveling ensures that writes are distributed evenly across each memory block. This feature necessitates non-volatile flash memory media being overwritten with a random pattern twice, as this helps to ensure that all memory blocks are overwritten. Security control. Non-volatile flash memory media is sanitized by overwriting it at least twice in its entirety with a random pattern followed by a readback for verification. Treatment of non-volatile flash memory media following sanitization. Due to the use of wear leveling in non-volatile flash memory media, and the potentially for bad memory blocks, it is possible that not all memory blocks will be overwritten during sanitization processes. For this reason, secret and top secret non-volatile flash memory media retains its classification following sanitization. Security control. Following sanitization, secret and top secret non-volatile flash memory media retains its classification. Media that cannot be successfully sanitized. In some cases, sanitization processes will be unsuccessful due to faulty or damaged media. In such cases, the faulty or damaged media will need to be destroyed prior to its disposal. Security control. Faulty or damaged media that cannot be successfully sanitized is destroyed prior to its disposal. Media destruction. Media destruction processes and procedures. Documenting processes and procedures for media destruction will ensure that an organization carries out media destruction in an appropriate and consistent manner. Security control. Media destruction processes, and supporting media destruction procedures, are developed and implemented. Media that cannot be sanitized. Some media types are incapable of being sanitized. As such, they will need to be destroyed prior to their disposal. Security control. The following media types are destroyed prior to their disposal. Microfiche and microfilm. Optical discs. Programmable read-only memory. Read-only memory. Other types of media that cannot be sanitized. Media destruction equipment. When physically destroying media, using approved equipment can provide a level of assurance that the data it stores is actually destroyed. Approved equipment includes destruction equipment listed on the Security Construction and Equipment Committee, SCEC's Security Equipment Evaluated Products List, and in the Australian Security Intelligence Organisation, ASIO's Security Equipment Guide, SEG 009, optical media shredders and SEG 018, destructors. ASIO's SEG 009 and SEG 018 are available from the Protective Security Policy Gov Teams community or ASIO by email. If using degaussers to destroy media, the United States National Security Agency maintains an evaluated products list for magnetic degaussers and information on common types of magnetic media and their associated magnetic field strengths and orientations. Security control. SCAC or ASIO approved equipment is used when destroying media. Security control. If using degaussers to destroy media, degaussers evaluated by the United States National Security Agency are used. Media destruction methods. The destruction methods identified below are designed to ensure that recovery of data is impossible or impractical. Security control. Equipment that is capable of reducing microform to a fine powder, with resultant particles not showing more than 5 consecutive characters per particle upon microscopic inspection, is used to destroy microfiche and microfilm. Security control. Electrostatic memory devices are destroyed using a furnace/incinerator, hammer mill, disintegrator or grinder/sander. Security control. Magnetic floppy disks are destroyed using a furnace/incinerator, hammer mill, disintegrator, degausser or by cutting. Security control. Magnetic hard disks are destroyed using a furnace/incinerator, hammer mill, disintegrator, grinder/sander or degausser. Security control. Magnetic tapes are destroyed using a furnace/incinerator, hammer mill, disintegrator, degausser or by cutting. Security control. Optical discs are destroyed using a furnace/incinerator, hammer mill, disintegrator, grinder/sander or by cutting. Security control. Semiconductor memory is destroyed using a furnace/incinerator, hammer mill or disintegrator. Security control. Media destroyed using a hammer mill, disintegrator, grinder/sander or by cutting results in media waste particles no larger than 9 mm. Treatment of media waste particles. Following the destruction of secret and top secret media, normal accounting and verification processes and procedures do not apply. However, depending on the destruction method used, and the resulting media waste particle size, it may still need to be stored and handled as classified waste. Security control. The resulting media waste particles from the destruction of secret media is stored and handled as official if less than or equal to 3 mm, protected if greater than 3 mm and less than or equal to 6 mm, or secret if greater than 6 mm and less than or equal to 9 mm. Security control. The resulting media waste particles from the destruction of top secret media is stored and handled as official if less than or equal to 3 mm, or secret if greater than 3 mm and less than or equal to 9 mm. Degaussing magnetic media. Degaussing magnetic media changes its magnetic properties, thereby permanently corrupting data. When degaussing magnetic media, care needs to be taken as a degausser of insufficient magnetic field strength will not be effective. In addition, since 2006 perpendicular magnetic media has progressively replaced longitudinal magnetic media. As some older degaussers are only capable of destroying longitudinal magnetic media, care needs to be taken to ensure that a degausser with a suitable magnetic orientation is also used. Furthermore, to ensure that degaussers are being used in the correct manner to effectively destroy magnetic media, product-specific directions provided by degausser manufacturers should be followed. Finally, to provide an additional level of assurance following the use of a degausser, magnetic media should be physically damaged by deforming any internal platters. Security control. Magnetic media is destroyed using a degausser with a suitable magnetic field strength and magnetic orientation. Security control. Product-specific directions provided by degausser manufacturers are followed. Security control. Following the use of a degausser, magnetic media is physically damaged by deforming any internal platters. Supervision of destruction. To verify that media is appropriately destroyed, destruction processes need to be supervised by at least one person cleared to the sensitivity or classification of the media being destroyed. Security control. The destruction of media is performed under the supervision of at least one person cleared to its sensitivity or classification. Security control. Personnel supervising the destruction of media supervise its handling to the point of destruction and ensure that the destruction is completed successfully. Supervision of accountable material destruction. The successful destruction of media storing accountable material is more important than for other media. As such, its destruction should be supervised by at least two personnel who sign a destruction certificate afterwards. Security control. The destruction of media storing accountable material is performed under the supervision of at least two personnel cleared to its sensitivity or classification. Security control. Personnel supervising the destruction of media storing accountable material supervise its handling to the point of destruction, ensure that the destruction is completed successfully and sign a destruction certificate afterwards. Outsourcing media destruction. National Association for Information Destruction AAA certified destruction services with endorsements can be used for the outsourced destruction of media, as specified in ASIO's Protective Security Circular, PSC-167, external destruction of security classified information. ASIO's PSC 167 is available from the Protective Security Policy Gov Teams community or ASIO by email. Security control. When outsourcing the destruction of media to an external destruction service, a National Association for Information Destruction AAA certified destruction service with endorsements, as specified in ASIO's PSC 167, is used. Security control. The destruction of media storing accountable material is not outsourced. Media disposal. Media disposal processes and procedures. Documenting processes and procedures for media disposal will ensure that an organization carries out media disposal in an appropriate and consistent manner. Security control. Media disposal processes, and supporting media disposal procedures, are developed and implemented. Disposal of media. Before media can be released into the public domain, it needs to be sanitized, destroyed or declassified. As sanitized, destroyed or declassified media still presents a security risk, albeit very minor. An appropriate authority needs to formally authorize its release into the public domain. Furthermore, as part of disposal processes, removing labels and markings indicating the owner, sensitivity, classification or any other marking that can associate media with its prior use will ensure it does not draw undue attention following its disposal. Security control. Labels and markings indicating the owner, sensitivity, classification or any other marking that can associate media with its prior use are removed prior to its disposal. Security control. Following sanitization, destruction or declassification, a formal administrative decision is made to release media, or its waste, into the public domain. This is the end of Part 9. Please subscribe and like for more content. More parts will continue.